So, good evening for all of you. Anyway, I'll be recording the session because so if someone wants, I can give them. Otherwise, I would have start earlier if you said me that. I hope if you said me that only four of you are there for the lecture, Kela, that's fine. So here we will be discussing today about the data modeling part. If you go through with the entire course specification, whatever the thing we have already done. So today we will be discussing about the data modeling part. So here, what is database? We already talked about this last week as well. So a database is an organized collection of data that can be easily accessed, managed, and updated as well. So that part we already discussed last time. Unlike random file or spreadsheets, earlier last week we talked about the file management system, how we do the file management system manually. So unlike those random files or random spreadsheets, databases store data in structured way as a table wise. So last week we discussed about that tables as well. When it comes to table, we had two main parts. That is, one is for the rows. For the rows, we are saving or per row we called it as a special name. We gave it as a special name. That's what we said as the record. Then for the column wise also, we are normally mentioning, we are saving the field data in column wise. So here, unlike the random file or spreadsheets, those databases store data in structured way. They allow efficient retrieval, updating, and management of large amounts of information. So for example, we have so many systems nowadays in Sri Lanka as well. We have banking systems, we have hospital systems, we have library management systems. So in each and every system, we are using a database part as for the backend. So this is how it works. And then the next one is, what is database management system? This one also we already talked about last time. This is also, we can say, this is not a physical component. We can't touch this for database management systems. Because of that, this is also a software. This is also a software. For why we use this software? This is to manage all these databases. What are the things it stores? Yes, it stores and organizes the database management systems. And what are the things they provide? Yes, CRUD operations, C for create, R for read, U for update, and D for delete. These are the main four operations we can have in databases: create, read, update, and delete. And finally, ensure security, consistency, concurrency control, backup, and recovery. These ones also last time we already discussed. Kind of yes, concurrency ones. These are the benefits, Kiela. What are the benefits which we can take the use of this database? Are the security side, it will improve the consistency, we can have a proper consistency, and also concurrency control, we can do kind of a proper concurrency control, and also we can have a proper backup. If something happened to our databases, we can easily, if we run or if we have a proper database management system, we can easily recover the stuffs we had as well. So these are the main things that we have. So for examples, we can see MySQL, PostgreSQL, and also MongoDBs. Especially, we are using this MongoDB for non-SQL stuff and for the oracles as well. These are the things that we should know. Okay. Then why do we need databases? Why do we need databases? A software that manages databases. Yes. Why we need all these databases? A software that manages databases, and also it stores and organize all these. Okay, this one we already discussed about those ones. Now, today we are starting from the data models. Here in data models, what are the types of data models we have? What are the types of data models we have? Before that, we should know what is a data model. So a data model is a way to organize and describe data in a database. Why we use these data models? Data models we use as a way or as a method to organize and describe, to vistara karanna kiyala kiyanne describe data in a database. Database එකේ තියෙන සම්පූර්ණ දත්ත data ටික ඔක්කොම organize කරන්න, පිළිවෙලට සකස් කරන්න, ඒ වගේම ඒව හොඳට describe කරන්න, මොනවාද මේ තියෙන data විස්තර කරන්න, we can use these data models. What are the things it shows? Yes, this data models shows how data is stored, connected, and also used. අපි කොහොමද මේ data ඔක්කොම store කරලා තියාගන්නේ? How we store all these data and how we connected all these data. Now, when it comes to database management system, we might have multiple databases as well. So here, then we should know how we can connect all these data together and also how we can use these data as well. And helps us to, so these data models helps us to understand the structure of data as well. These are the, now we will be learning about what are the types of this data model, and for several specific tasks we are using special data models. So according to the context also, we can select what would be the most appropriate or what would be the suitable, I would say, model to use here. We can select and apply. So the structure will be, these data models acts as a blueprint for building a database. And what are the relationships we have? So for the relationships, describes how different data elements related to each other, and also those ones enabling effective retrieval and manipulation of information as well. So what are the examples we can have? We will be discussing these ones. One is hierarchical model. It's like a family hierarchy එකක් තියෙනවා. උඩම ඉන්න parents ලාගෙන් පස්සේ my children. Likewise, there's a small hierarchy going top to bottom. And for the network model, network now, it's anyway, it's like a lot of connections we are considering together. And also we have the relation model. For the relational model, like tables in Excel. So these are the examples and also the main data models, whatever we are going to talk. So the first one is about the relational model. So when it comes to relational model, here, first thing you should know what are the key concepts, tables tool, and also for the tables tool, and also attributes, relation schema, degree, cardinality, and the attribute domain. These are the main things that we should know when it comes to relational model. So relational model එකක් කියලා කිව්වහම relation එකක් තියෙනවානේ, there's a connection in between these ones. So there are relational integrity constraints. මොනවාද තියෙන limitations? අපි constraints කියලා කිව්වහම what are the limitations we have? Yes, we have three types of main constraints or limitations in our relational database models. So අපි relational database models කියලා කියන අපි සාමාන්‍යයෙන් භාවිතා කරන 2D model එකට tables වගේ අඳින normal database models වලට තමයි අපි relational database models කියලා කියන්නේ. එතකොට එතන තියෙන constraints එහෙමත් නැත්නම් limitations ගත්තොත් mainly we have three types of constraints. First one is the domain constraints. Domain constraints කියලා කිව්වම in SQL also sometimes you might have used these ones null, check, unique කියලා කියන keywords ඔක්කොම එන්නේ මෙන්න මේ domain constraints වලට. And for the key constraints ගත්තාම we have the entity integrity, and for the referential integrity constraints තියෙනවා සාමාන්‍යයෙන්. Basically මේ කියන තුන තමයි මේ කියන concepts තුන එහෙමත් නැත්නම් limitations තුන තමයි අපිට තියෙන්නේ relational models වල. Maybe you also have used some words called distinct. අපි distincts කියලා එක relations එහෙමත් නැත්නම් restrictions දානවා. ඊට පස්සේ null කියලා use කරනවා මුකුත් එතන values නැත්නම් check කරන්න නම් check කරන්න අපි use කරනවා. ඊට පස්සේ for unique values නම් අපි unique කියලා කියන keyword එක use කරනවා. මේවා තමයි අපිට තියෙන constraints. So relational integrity constraints ගත්තාම you should know these are the main three constraints whatever we have. And now one thing is about the relational integrity. No, the other thing is about the relational algebra. For the relational algebra, these are the functions or the tasks which we normally use in a relational model. එකක් තමයි selection. So selection තියෙනවා, අනිත් එක තමයි projection, union, intersection, difference and the cross product. What do you think? What do you think of these ones? Can you just search and have a write down an example for each and every relational algebras? Explain me. So what is selection? මොකක්ද ඇත්තටම selection කියන්නේ? Selection එකෙන් output එක විදිහට අපිට හම්බ වෙන්නේ මොකක්ද? And also what is the what is the symbol which we use normally for the selection, and kind of an example. හොයන්න බලන්න. Selections, projections, return, selections, projection, union, intersection, and the difference. here they have given us what are the a small introduction about the relational algebra. So when it comes to relational algebra in database management systems, what you should know is first, so what you should know is first, these are the main key concepts of the relational algebra. In a relational algebra, there are relations, that means the connections, and also we have tuples. For tuples means exactly a single row. That's what we earlier called as records. And then we have the attributes. At last, we have the domain. These are the four main concepts of key concepts in relational algebra. So when it comes to relations in relational algebra, a relation is a table that consists of rows and columns. අපි කියන්නේ relations කියලා සම්පූර්ණයෙන් අර table එකට ඒ table එක ගත්තොත් rows and columns එක්ක තමයි ඒක combine වෙලා හැදිලා තියෙන්නේ, and also it will representing data in a structured format. So each relation has a unique name and is made up of the tuple as well. එතකොට ඒක හැම රෝ එකක්ම ගත්තොත් හැම රිලේෂන් එකක්ම ගත්තොත් ඒකට ස්පෙෂල් යුනික් නේම් එකක් තියෙනවා අපි පාවිච්චි කරන, and also මේ කියන හැම රිලේෂන් එකක්ම ටුපල්ස් වලින් තමයි බිල්ඩ් අප් වෙලා තියෙන්නේ. එහෙනම් ඊළඟට තියෙන ප්‍රශ්නේ, what is this tuple? Tuple is a single row in a selection relation. අර රිලේෂන් එකක අපි කතා කරන එකම එක සිංගල් රෝ එකක් තමයි අපි කියන්නේ සම්පූර්ණයෙන්ම tuple එකක් කියලා. So here a tuple is a single row in a relation which contains a set of values for each attributes. දැන් මවා ගන්න හිතා ගන්න 2D table එකක්. ඒ 2D table එකේ row wise අපි ගාව තියෙනවා data records, column wise අපි ගාව තියෙනවා data fields. හරි, එතකොට අපි මේ tuple එකක් කියලා කියන්නේ a complete row. අපි tuple එකක් කියලා කියන්නේ is a single row of relation which contains a set of values for each attribute. අර කියන හැම attribute එකකටම values ඔක්කොම අන්තර්ගත වෙලා තියෙන, අඩංගු වෙලා තියෙන a complete row එකක් තමයි අපි කියන්නේ tuple එකක් කියලා. It represents a single data entry or record in a relational table. That's why I told you tuple එක කියලා කියන එකට තමයි අපි කලිනුත් record එකක් කියලා කිව්වේ. එහෙනම් then the next key point will be attributes. ඊළඟට අපි ගාව තියෙන්නේ attributes කියලා කියන්නේ anyway the properties. අපි කෙනෙක්ව හඳුන්වනවා නම් එයා හඳුන්වන qualities, ගුණාංග, properties තමයි අපි ගොඩක් වෙලාවට මෙන්න මේ attributes කියලා කියන්නේ. So for those attributes are the columns in a relations. ගුණාංග කියලා කියන්නේ qualities කියලා කියන්නේ. So for those attributes are the columns in a relation, each representing a specific characteristic or property of the data as well. For example, in a student's relation, attributes could be name, age, and grade as well. So for the domains now, we have domains means a domain is the set of possible values. අපිට මොනවාද ගන්න පුළුවන් possible values මෙන්න මේ fields විදිහට, එහෙමත් නැත්නම් attributes විදිහට. So a domain is a set of possible values that an attribute can have. So it defines the type of data. එක define කරනවා මොකක්ද හරියටම තියෙන data type එක කියලා. It defines the type of data that can be stored in each column of a relation, such as integers, strings, or dates as well. That's what we have. Okay, so the main key concepts in relational algebra will be relations, tuples, attributes, and domains. Then what are the basic operations we can have in relational algebra? මොනවාද අපිට තියෙන basic operations මෙන්න මේ relational algebra වල තියෙන. එහෙනම් basic operations ගත්තහම මෙන්න මේ ටික තමයි අපිට තියෙන්නේ. මොනවාද? We have the basic operations as well as we have the derived operators as well. ඒ කියන්නේ basic operators තියෙනවා. ඒ වගේම we have the derived operators as well. When it comes to basic operators, mainly project, set difference, අපි difference එක ගන්නවා, rename, union, select and the Cartesian product. මෙතනිනුත් I guess you already know about the union and the set difference and select also. Maybe sometimes you already have used these ones. And for the rename, basic operators. Okay, we have the select, project, union, rename, set difference, and the Cartesian products. Remember these symbols as well. මොකද selections කියලා කිව්වොත් we are using the sigma. This is what we called as sigma in Greek letters. Sigma කියලා කියන එක තමයි notation එක විදිහට අපි පාවිච්චි කරන්නේ. So එතන තියෙන්නේ selection first one, and then we have the projection එකේ symbol එක, that is phi. අපි phi කියලා කියන එක තමයි projection එකේ symbol එක විදිහට use කරන්නේ. මේක පොඩි mathematical part එකක් තියෙනවා, so ඒක නිසා හොඳට අල්ල ගන්න. මම one by one මේ හයෙන් කියවෙන්නේ මොනවද කියලා explain කරනවා. Then we have the union. Union නම් අපි අර sets ඉගෙන ගනිද්දී all over වලට maths කරනකොට union එක ඉගෙන ගන්නේ. set A and set B තියෙනවා නම් ඒ දෙකේම complete එක එකතුව කියලා. අන්න ඒ concept එකම තමයි we are applying here as well for the union. Union එකට නම් අපි U අකුර තමයි ගොඩක් වෙලාවට use කරන්නේ. Then we have the set difference. Set difference එක කියලා කියන්නේ not කියලා කියන එක. එහෙමත් නැත්නම් subtraction එක කියලා කියන එක. There we are applying this minus mark as the symbol. Then finally we have the rename option. Rename now we are applying the row. Row is the symbol that we apply here. And at last we have the Cartesian product. Cartesian product කියලා කියන එකට capital X tamai whatever we are using. These are the all 6 basic operators that we have here for the relational algebras. So I'll give you 5 minutes. Just read this one as well. You can find this same note there in the internet for the selections and projections. What are the differences in between these ones? Just take a look on that. I'll give you 5 minutes. කොහොමද ඒක වැඩ කරන්නේ කියලා? Geeks for Geeks, the site. හරි බලුවද? So for the selection මොකක්ද selection එකෙන් වෙන්නේ? What does this selection do? What does this selection do? That is only filtering out. For example, balanna metana we have three columns, three fields, A, B, and C. Now this one is a table. So for this entire table, let's assume if we have a relation R with attributes A, B, C, that the field names are A, B, C, and we want to select the tuples where the C value is greater than 3. Then what should be the output? Output එක විදිහට එන්න ඕනේ. එහෙනම් C value එක 3ට වඩා වැඩි වෙච්ච entire value set එක. So එහෙනම් ABC fields තුනම තියෙනවා. We have to compare all the C values. C value එක 3ට වඩා වැඩි කියලා කියන්නේ we have only two rows. First row and the last row. එහෙනම් our final output should be this. A, B, C, 1, 2, 4, 4, 3, 4. Then may avilla අපේ table එක input values ටික, and then we have the output value. Habai the main thing or the important thing that you should know is මොකක්ද ඔයා දැනගන්නම ඕනද how to define this in a relational algebra. එතකොට අපි මේක explain කරන්නේ we are discussing about the R relation. එහෙනම් sigma we have to only select those ones or filter those ones. So we have to use sigma. Then inside the small bracket we have to mention the condition. අපි මෙතන නම් condition එක විදිහට අපි පාවිච්චි කරන්නේ මොකක්ද? මෙන්න මේ C value එක greater than 3 කියලා. So sigma represents the selection part, and then C greater than 3 means our selection criteria or the condition. අපි ඒක check කරන්නේ R කියලා කියන table එකේ all the relation. එහෙනම් how do we define this? Sigma C greater than 3R will select the tuples which have C value is more than 3. ඕක මෙන්න මේ ටික තමයි අපි relational algebra වලින් define කරන්නේ. ඕගොල්ලෝටත් exam එකට tables කීපයක් දීලා relational algebra එක දීලා output එක මොකක්ද කියලා අහුවොත් you should be able to draw or find out the final output whatever they are discussing. Is it clear for the selection part? Okay. Then hari ඊළඟට බලන්නකො projection එක. So each what we have to know is from each and every operation මොකක්ද ඒගොල්ලෝ කියන්නේ, what is the method or why we use those ones. ඊට පස්සේ we should know, we should learn how to denote these ones. එතකොට exam එකට වුණත් relational algebra එකක් ලියන්න කියලා කිව්වොත්, එහෙමත් නැත්නම් ලියලා දීලා තියෙන එකක output එක හොයන්න කියලා කිව්වොත් you should be able to do it. So projection means while the selection operation works on rows, or a selection operation එකෙන් completely කරන්නේ row wise values ඔක්කොම select කරන එකනේ. හැබැයි what will happen in projection? Projection, similarly the projection operation of relational algebra works on the columns. Columns තමයි check කරන්නේ මෙන්න මේ projection එකේදී. For example, for the projection, we are using the phi. එතකොට phi, now the example is, suppose we want columns B and C from relation R. අර relation R කියලා කලින් අපි select කරගත්ත එකේ අපි ගාව තිබ්බ complete relation R එකේ columns ටිකක් විතරයි නම් ඒ කියන්නේ අපිට selection එක කරන්න ඕනේ එහෙමත් නැත්නම් criteria එක check කරන්න ඕනේ row wise නෙවෙයි නම් we only need the column wise data now we can go with this projection part. එතකොට මෙතන මේ කරලා තියෙන්නේ phi represents the projection. What is the target or what is their goal? That is to they just wanted to retrieve the data of column B and column C. එහෙනම් column B and column C වල data set එක විතරයි ඒගොල්ලන්ට ගන්න ඕනේ. So for that, phi BCR will show following columns. බලන්න මෙතන initially මෙන්න මේ ටිකනේ තිබ්බේ. This one was our what we call the input values or the complete relation. මේ relation එකෙන් BC කියන එක ගත්තාම you can see we have 4 rows. හරි? ඔයාට පේනවා 2 4 2 3 2 3 and 3 4. But remember, when it comes to projection, they're removing the duplicates. හොඳට මතක තියාගන්න ඒගොල්ලෝ මේ output එක අරගත්තාම 2 4 2 3 2 3 3 4 කියලා rows ගත්තොත් rows 4ක් එනවා. හැබැයි rows 4ෙන් they will do another duplicates removal part and then display only the 2 4 2 3 3 4 only as the final output. හරිද? ඒක නිසා තමයි, that's why we are having this output 2 4 2 3 3 4. හරිද? ඒක තේරුණාද? That's also fine. Okay, now check for the union and the union, and then we have the set difference. මොකක්ද ඒ operation එකෙන් කියන්නේ, and also how to write the notation එකෙන් ලියන්නේ notation එකෙන් ඒ කියන ඒවා ලියන්නේ කොහොමද, and also how we can find out the final output according to the given relation. Those are the things that we should know. The third one will be the union. Third one will be the union. Then for the union, what does that mean? Okay, just finish. Okay. So for the union means what? The addition actually. Addition කියලා කියන්නේ ඒ දෙකේම සම්පූර්ණයෙන් එකතුවක් කියලා කියන එක තමයි අපි normal අර set theories වල අපි ඉගෙන ගන්නේ O levels වලදී union කියලා කියන්නේ මොනවාද sets දෙකේම තියෙන elements වල එකතුව කියලා. අන්න ඒ වගේ දෙයක් තමයි මෙතන union එකේදී කියන්නේ. So union operator is basically used to combine the results. අර ඔක්කොම results ටික එකට එකතු කරලා combine the results of two queries into a single result. එක single result එකකට අපි ඒක දානවා. The only condition is that both queries must return the same number of columns with same data types. එතකොට data types උත් ඔක්කොම similar වෙන්න ඕනේ. Same number of columns ප්‍රමාණයක් ඒගොල්ලෝ ගාව තියෙන්නත් ඕනේ අපි check කරන tables දෙකේම. For example, මෙතන තියෙනවා tables දෙකක්. එහෙමත් නැත්නම් relations දෙකක්. ඒ relations දෙකේම තියෙන column names මොනවාද වෙලා තියෙන්නේ? එකම column names. හදිසියෙන්වත් එක table එකක fields දෙකක් විතරක් තිබිලා columns දෙකක් විතරක් තියලා අනිත් table එකේ columns තුනක් වගේ තියෙනවා නම් අනිත් relation එකේ columns තුනක් තියෙනවා නම් එහෙනම් we can't do this union part because the number of columns or the number of fields we should have the same number of fields in both relations. එතකොට මෙතන කියනවා same number of columns with the same data types. Union operation in algebra, relational algebra is the same as union operation in the set theories as well. So what now the example, consider the following table of students having different optional subjects in their course. Then අපිට කියනවා මෙන්න මේ students tables ටික ඒ කියන්නේ consider the following table of students අපිට student table එක consider කරන්න කියලා කියනවා having different optional subjects in their courses. First set එකේ ඉන්නේ French කියලා කියන එක study කරන අය, second set එකේ ඉන්නේ German කියන එක study කරන students ලා. දැන් අපේ target එක මොකක්ද? If French and German relations represent student names in two subjects, we can combine their student names as follows. Then කොහොමද අපි ඒක check කරන්නේ combine කරන්නේ? අපි for the what we call why we use this file, that is we are only considering about the column data ගැන විතරයි අපි කතා කරන්නේ. එහෙනම් French කියලා කියන relation table එකේ තියෙන student name එක combine කරනවා German කියලා කියන relation එකේ තියෙන student name එකත් එක්ක. එතකොට the final output will be Ram, Mohan, Vivek, Geeta, Shyam. මේ කියන නම් පහ විතරයි මෙතන එන්න ඕන. Ram, Mohan, Vivek, Geeta, Shyam, Rohan කියලා නමකුත් තියෙනවා. Rohan also there. So මේ ටිකේම එකතුවක් තමයි එහෙනම් අපිට එන්නේ. එතකොට මෙතනින් output එකට අපිට එන්නේ only the student name because we project only the student name. අපි combine කරන්න පාවිච්චි කරේ student name කියලා කියන එක විතරයි. ඒක නිසා අපේ display එකේ එහෙමත් නැත්නම් final output එකේ අපිට හම්බ වෙන්නේ student names values ටික විතරයි. Here we are not considering row wise data, we are considering only the column wise data. අපි check කරන්නේ student name කියලා කියන එක both the French relation as well as the German relation. Harida, is it clear? Okay, that's also fine. Then we have the set difference. Set difference also check කරන්න කොයික unless set difference. Set difference එකේදී කරන්නේ normal subtraction එකක් වගේ කතාවක්. Set difference කියලා කියන්නේ normally අපි ගත්තොත් subtraction එක වගේ දෙයක්. Fourth and fifth check කරන්නකො for the set difference and the rename part. Rename part එක නම් it's already there. So for the set difference now, here set difference basically provides the rows that are present in one table but not in another table. Subtraction එක වගේ කතාවක් එකකින් අනිත් එක අඩු කරනවා. එක table එකක තියෙනවා හැබැයි අනිත් table එකේ නැහැ. So set difference in relational algebra is the same set difference operations as in the set theory. So what they define here, example එක දීලා තියෙනවා to find students enrolled only in French but not in German. දැන් කියන්නේ මොකක්ද? enroll කරපු students ලා කවුද කියලා බලන්න කියලා කියනවා. only in French අපේ condition එක ඒ කට්ටිය enroll වෙලා ඉන්න ඕනේ French වල විතරයි but not in German. German වලට enroll වෙලා ඉන්න බෑ. එහෙනම් අර ඔක්කොම ඉන්න French table එකෙන් German වලට enroll වෙලා ඉන්න අයව අපි අඩු කරොත් එහෙමත් නැත්නම් කැපුවොත් then we have only people then we have the people who selected or who enrolled only for French but not in German. එතකොට what would be the output? මෙතන output එක විදිහට එන්නේ Ram and Rohan විතරයි. හරිනේ. Ram and Rohan විතරයි. මොකද විවේක් ගීතා අනිත් එකනා කවුද? Ram Rohan විතරයි. Vivek and Geeta both are in what we call German as well. Egolo, they have already enrolled for the German as well. හරිද? ලියන විදිහ තමයි relation algebra එක ලියන විදිහ තමයි most important. 5 student name French minus is for the set difference minus 5 student name German. Here we will be only discussing or only considering about the first field or the student name field. We are not checking record by record. අපි record wise මුකුත් selection එකක් කරන්නේ නැහැ. ඒක නිසා අපි selection එක use කරන්නේ නැහැ. මෙතන use කරන්නේ only the projection. Okay. Then we have the rename part. For the rename, operator basically allows you to give a temporary name to a specific relational table or to its columns as well. It is very useful when we want to avoid ambiguity, especially in complex queries. Rename is a unary operation used for renaming attributes of a relation as well. That's what we have. Okay. So example, we can rename an attribute B in relation R O D. Then කොහොමද ඒක ලියන්නේ? අපි relation එකක් rename කරනවා නම් we have to use the symbol or notation. That's what we call row D. Then rename කරන්න ඕනේ මොකක්ද? We can rename an attribute B in relation R to D. එහෙනම් D කියලා කියන එක විදිහට ඒ කියන්නේ B කියලා කියන එක we have to rename with D. So check for the method that we are writing here. ඉස්සලම rename කරන value එක තමයි ඉස්සලා ලියන්නේ. rename කරන්න ඕන එක තමයි අපි පස්සේ ලියන්නේ. Here again we are considering the relation R. So we have to go with row D/B R. We'll rename the attribute B of the relation by D. So එතකොට අලුත් out අද මේක ඕන වෙනවා ඔයගොල්ලන්ට මේ මොනවාද field names rename කරන්න එහෙම වුණාම tables වල then we have to go with this method. So here then the output table will be now B we already replaced with D. So we have A, D, C. We can have the same table or the same relation. Okay, that is there. Is it clear up to this point? Okay, fine. Then for the last one, that is for the Cartesian product. Cartesian product combines unknown. For the Cartesian product, there we are applying this into rows. Combines every row of one table with every row of another table. එක table එකක තියෙන සම්පූර්ණ rows අනිත් table එකත් එක්ක combine කරන එක තමයි මෙතන Cartesian product එකේදී වෙන්නේ. So here another table producing all the possible combinations. It's mostly used as a precursor to more complex operations like joins. දැන් මෙතන නම් relation A එක තියෙනවා, relation B එක තියෙනවා. මේ to apply the Cartesian product thing, no need to have all three same columns. Here with the both relations. මෙතනදී අපිට අර same columns තියෙන්න ඕනේ කියලා කිව්වේ with the same data types. ඒ condition එක මෙතනට ඕනේ නැහැ. Because we are combining අර row wise නේ අපි combine කරන්න values. So එතකොට අපිට මේකේ different data fields තිබ්බට issue එකක් නැහැ. හැබැයි මොකක් හරි එක method එකක් එක common value එකක් අපිට තියෙන්න ඕනේ use කරන්න පුළුවන්. So here it's mostly used as a precursor to more complex operations like joins, let's say A and B. So the cross product between A and B will result in all attributes of A followed by each attribute in B. එහෙනම් ඇත්තටම කියනවා නම් මේක හැදුවොත් අපි combine කරලා cross product එක විදිහට කොච්චරක් ඒ කියන්නේ final relation එකේ අපි ගාව කොච්චරක් rows තියනවද? ඇත්තටම කියනවා නම් අපි ගාව rows 6ක් තියෙනවා. මොකද RAM කියන students rows දෙකක් එනවා. Sona කියන students again rows දෙකක් එනවා. Kim කියන student again rows දෙකක් එනවා. ඔක්කොම ටික combine කරාම see we are having an entire relation or the final output will be with 6 data records. මෙන්න මේ 6 වෙන විදිහට තමයි combine වෙන්නේ. තේරුණාද ඒක? හැදිලා තියෙන විදිය cross එක. අර first table එකේ relation A එකේ තියෙන සියලුම rows ගත්තොත් complete rows මෙතන තියෙන followed by කියලා එනවනේ second relation table එක. ඒකේ තියෙන හැම value එකත් එක්කම combine වෙනවා. හැම data row එකක් එක්කම combine වෙනවා. record එකක් එක්කම combine වෙනවා. එතකොට අපි ගාව cross multiplication එකක් මෙතන වෙන්නේ. ඒකයි අපි මේකට Cartesian product එකක් කියලා දාලා තියෙන්නේ. So එතකොට 3 times 2 අපිට 6 number of columns 6 number of rows හැදෙනවා අපේ final output එකේ. අපි ඒක define කරන්නේ A cross B කියලා for this example. හරි ඔන්න ඔය විදිහට තමයි main 6 operations work. මේ තියෙන්නේ අපි කතා කරපු basic operators ටික. Okay, so a relational model, we are done with these ones. Selection, projection. Ekai selection and projection. Here I have mentioned return rows, but for the projection, we are returning the column values only. So that part we already did. Tables, tuple and attributes also we already discussed. Just read this slide. So here it says the relational model is an example of an implementation model or representational model. So the relational model represents a database as a collection of relations. Hari. And a relation is a table of values, and each row in the table represents a collection of related data values. And in the relational model terminology, a row is called a tuple. That's why I told you an entire record. We called it as a tuple. And a column header is called as an attribute, and the data type describing the types of values that can appear in each column is called a domain. So those ones we already discussed with the previous entire session. So tables are there. In a relational model, the relations are saved in the table format. අපි කතා කරන table එකකට තමයි automatically relational model එකක් කියලා කියන්නේත් relation එකක් කියන්නේත්. So it is stored along with its entities. A table has two properties, rows and columns. Rows represents records and columns represents the attributes. So tuple now, it's nothing but a single row of a table which contains a single record. And for the attribute now, each column in a table. So the attributes are the properties which define a relation. For example, we have the student roll number, name, and etc. We already discussed. So then we have the relational schema. For the relational schema, a relational schema represents the name of the relation with its attributes. අපි attributes එක්ක සම්පූර්ණයෙන් මේ කතා කරන relational schema එකක් කියලා කියන්නේ relations ඔක්කොම relational attribute එක්කම ගත්තාම තමයි අපි කියන්නේ ඒකට relational schema එකක් කියලා. And then you should know what is degree. Degree means the total number of attributes, total number of attributes which in the relation is called the degree of the relation. කොච්චර attributes ගානක් තියනවද කියලා කියන එක ඒක තමයි අපි degree එක කියලා consider කරන්නේ. And then we have the cardinality. Cardinality means the maximum number of, or the number of rows present in the table. Table එකේ තියෙන number of rows ගාන තමයි අපි cardinality කියලා කියන්නේ. And for the attribute domain now, every domain has some predefined value and scope which is known as attribute domain. That's what we have. Okay, so that part also done. Then relational integrity constraints, මොනවාද මේක integrate කරද්දී අපිට තියෙන constraints කියලා ගත්තොත් relational integrity constraints is referred to conditions which must be present for a valid relation. ඇත්තටම පවතින valid relation එකකට වෙන්න ඕනේ අපි මේ ටික define කරන්නේ. So these integrity constraints are derived from the rules in the mini world that the database represents. අපි database represents කරන ඒ domain එක ඇතුලේ ඉඳන් තමයි අපි කොහොමත් මේවත් define කරන්නේ. There are many types of integrity constraints. අපි ඉස්සෙල්ලාම කිව්වානේ 3 main types of integrity constraints තියෙනවා කියලා. හැබැයි we didn't discuss each of these ones. එතකොට constraints on the relational database management system is mostly divided into 3 main categories. First one, entity integrity. Entity integrity කියලා කියන එකේ එක condition එකක් තමයි අපි define කරනවා primary key එකක්. Primary key එක කියලා කියන්නේ ඒ අදාළ relation එකට unique key එක. It can't be null. ඒකේ මුකුත් value එකක් නැති වෙන්න බෑ. Null values තියෙන්න විදිහක් නැහැ. His values තියෙන්න විදිහක් නැහැ. So the primary key cannot be null. That's the first thing. Then we have to ensure every row is uniquely identifiable. Duplicates මුකුත් තියෙන්න බෑ. හැම row එකක්ම uniquely අපිට identify කරගන්න පුළුවන් කියලා පුළුවන් වෙන්න ඕනේ. It's also an entity integrity. Then we have the referential integrity. For that referential integrity, foreign key values must exist in the referenced primary key, and also example එකක් දීලා තියෙනවා enrollment course ID must exist in course course ID as well. දැන් හදිසියෙන්වත් අපි enrollment table එකයි course table එකයි දෙක එකට connect කරනවා නම් අර අපේ foreign key value එක අපි foreign key එක විදිහට define කරන එක අර දෙන්නගෙම tables දෙකෙම තියෙන්න ඕනේ. නැත්නම් අපිට connection එක හදාගන්න විදිහක් නැහැනේ. එතකොට enrollment course ID must exist in the courses වල තියෙන course ID එකත් course ID එකෙත් තියෙන්න ඕනේ. එහෙම නැත්නම් we can't connect those two tables together. Final one, that is the domain constraints. Domain constraint එකේ වෙන්නේ මොකද්ද? Values in an attribute must conform to a valid type or range. For example, each column must be greater than or equals to 0. Always it should be a positive value. ඇත්තටම 0 වෙන්නත් බෑ. age එක කියලා කියන එක student කෙනෙක්ගේ age එක. Obviously it should be a positive value. එහෙනම් අපිට age column එකට constraint එකක් දෙන්න පුළුවන්. අපි input කරන value එක it should always be a positive value කියලා. අර non-negative values කියලා. අපි identity card එක input කරන්න තියෙන තැන් වල validate කරන්නේ ඔයගොල්ලෝ අහලා ඇති validations තියෙන system එකේ ඔයගොල්ලෝ වැරදි ID number එකක් එහෙම input කරොත් ටක් ගාලා ඒක හරි validations තියෙන හරි system එකක් නම් it will give you a pop-up error message saying the entered validation is not entered NIC is not exist or මොකක් හරි එක්ක ඔයාගේ username and password දෙක match වෙන්නේ නැහැ. ඒ වගේ මොන හරි information එකක් පොඩි detail එකක් ඕගොල්ලන්ට output එක විදිහට එනවා. එහෙම එන්නේ අර database එකේ save කරලා තියෙන value එකත් එක්ක ඔයා input කරන value එක check කරද්දී so මේ වගේ අපිට constraints ඒවට use කරන්න පුළුවන්. Okay. Then we have another three. For the fourth one, unique constraints. So attributes must have unique values. For example, email in student table and also not null constraints, null values when all the attributes cannot have null values. Attributes වලට මුකුත් null values තියෙන විදිහක් නැහැ. Example, student ID, name cannot be null. And for the check constraints ගත්තොත් the restrict values according to a condition. For example, we have the grade must be between 0 and 100 as well. These are the relational integrity constraints that we have. Then we have the hierarchical model. Hierarchical model එක කරන්න කලින් Okay, hierarchical model and the network model. මේ දෙකේ ගොඩක් වෙලාවට in this course we are focusing on the relational models, but I'll explain what are these hierarchical models and also the network models as well. මොකද මේ දෙකත් දැනගෙන ඉන්න එක හොඳයි. Hierarchical model එකක් කියලා කිව්වම මම කියන්නේ අර tree structure එකක් තියෙනවා කියලා. So here for this hierarchical model we have a tree structure. අපිට තියෙනවා පොඩි tree structure එකක් and also it organizes data in a hierarchical tree structure with hierarchical tree structure එකක් තියෙනවා නම් always we have the parent child relationship in between these elements. අපි ගාව parent child පොඩි මොකක්ද ඒකට කියන්නේ parent child relationship එකක් තියෙනවා in between these elements. And for the top down approach නම් top down approach එක තමයි ගොඩක් වෙලාවට මේ තියෙන hierarchical model එකේදී යන්නේ. For the top down approach, data is accessed in a top down approach. මොකද අම්මා තාත්තා ඉන්න පෑ ළමෙක් හැදෙන්න නම් so එහෙනම් parent එකේ ඉඳන් තමයි අපි පල්ලෙහාට යන්නේ from top to bottom තමයි යන්නේ. So data is accessed in a top down approach starting from the root node. අර උඩම ඉන්න node එකට තමයි අපි කියන්නේ root node කියලා and traversing down the branches. අපි අර අත්ත දිගේ branches දිගේ පල්ලෙහාට එනවා. For the example used in early database systems, ගොඩක් වෙලාවට ඉස්සර තමයි මේක use කරේ, such as IMS, information management systems, and some legacy systems as well. What are the advantages and disadvantages of these ones? When it comes to advantages, it's a simple structure, fast data retrieval, efficient querying. We can query very easily, and the data integrity also simple and it's also like easy and controlled access and security. These are the advantages of that. And for the disadvantages now, rigid structure and the insertion and the deletion is a little bit hard, and also we have so many constraints there, because we can't easily insert values in the middle of that branch. මොකද මේක දැන් parent node එකක් parent and child connection එක විදිහට පල්ලෙහාට හැදිහැදීනේ යන්නේ. so එහෙනම් අපිට අර එක connection එකක් completely ගලවලා මැදට ඒ value එක දාලා ඊට පස්සේ තමයි මේ links දෙක connect කරන්න වෙන්නේ. but it won't technically හිතුවොත් මේකේ parent child connection එක නම් තියෙන්නේ, it's not correct. so එහෙනම් insertion and the deletion constraints are there, and the complex queries for non-hierarchical data, difficult data modifications, and the complex management and the maintenance as well. And another model, data model, will be the network model. A network model එකේ නම් අරකේ හරියට branches වලින් යටම තිබ්බනේ අපේ leaf nodes, එහෙමත් නැත්නම් ඒව ඇවිල්ලා connect වෙලා තිබ්බේ නැහැනේ. මේ network diagram එක කියලා කියන්නේ ඔක්කොම එකට අර network එකක් වගේ connect වෙලා තියෙන්නේ. යටම node එකේ බලන්න ඕගොල්ලෝ මෙතන මේ තිබ්බ ඒවා එකට connect වෙන්නේ නැහැ. but here in the network nodes sometimes මේක සම්පූර්ණයෙන් අපි අරගත්තොත් මේකේව ඔක්කොම එකට connect වෙනවා. extends hierarchy එක තව extend වෙනවා. ඊට පස්සේ extend the hierarchical model by allowing multiple parents. එකම child parents ලා කීප දෙනෙක් ඉන්නත් පුළුවන් මේ method එකේ. ඒ වගේම එකම parent childs ලා කීප දෙනෙක් ඉන්නත් පුළුවන්. allowing multiple parent child relationships between the elements. කලින් එකේ නම් අර direct branches තමයි ගියේ. හැබැයි දැන් එකේ එහෙම නැහැ. So here data sharing provides better data sharing and flexibility compared to the hierarchical model, and for the complexity can become complex to manage due to the intricate relationships and connections between data elements as well. So again, we have the advantages and the disadvantages. It should be advantages and the disadvantages. So for the advantages, we have simple and easy design, can handle multiple types of relationships, easy access, data integrity, and the controlled access and the security. For the disadvantages, not user-friendly, complex in nature, බලුවහම දැන් අර තරම්නුත් නෙමෙයි parent child එකත් එකට connect වෙලා තියෙනවා, existence of operational anomalies, no query optimizations. These are the disadvantages of the network data model. And then, yes. And then here again we have two slides for the relational data model, tables and the relations, foreign keys and the structured data. So for the tables and the relations, now we already discussed, organizes data into tables, which each table representing a distinct entity such as the customer or product. Foreign keys means we can connect the multiple tables, relates tables using foreign keys, which reference primary keys in other tables, establishing a relationship between entities. And for the structured data now, uses the structured data stored in tables with rows representing records and columns representing attributes as well. That's also, you already know about that. And then the advantages and the disadvantages. Yes, for the relational data model now, we have as the advantages, it's simple, it's flexible, it's more secured, data also accuracy, data integrity, and the operations can be applied very easily. So these are the advantages. When it comes to disadvantages, relational databases model is not good for large databases. Sometimes it becomes difficult to find the relational between the tables because of the complex structure. The responses time for the queries is also high. These are the advantages and the disadvantages of the relational data model. Okay, so we are already done with the data models. Data models means when it comes to the relational model and also the hierarchical model and also the network model. All those three we have already completed, because the advantages and the disadvantages now you all can read it and understand. For this level we are learning in deep only about the relational data. Any questions up to this point? Monahari prashna tiyena metanta venaka. I think today you can see the slides, right? Clearly rather than last times. Okay. Okay, then yeah, anyway, now it's 2:50. You can have a small break and then we can start with the ERD diagrams and the drawing part. Yes, we can start in 20 to 25 minutes. We can start the next session. Okay. There are another three models, data models that we have to go through. The first one is the entity relationship model. So for the entity relationship model, first thing you should know, this is something like this. There are so many notations or symbols which we are using, to represent those ones for the entities and relationships. And also when it comes to relationships also, either those ones are like loosely coupled or is it fixed. And when it comes to attributes also, there are multi-valued attributes and composite attributes. There are so many things that we can represent in this entity relationship model. So when it comes to entity relationship model, we have the visual representations, and also we have we can use these ones to design all these databases. And also we have to understand all these relationships as well. When it comes to visual representation, it will provide a visual representation of data entities and their relationships using the diagrams. That's what we do with this ER diagrams or ER model. And for the designing databases now, we can use as a designing tool as well to model data before implementing a database system. That's also a purpose of this ER diagrams or ER data models. Then for the understanding relationships, it will help to understand the structure of data and how different these entities interact within the databases. Those are the few things that we do with this ER diagrams. We will be discussing each and every element and the symbol here, whatever we have here, in future slides as well. Anyway, when it comes to ER diagrams, there we have entities and also the relations. ER means the entity relationship model or the diagram. There we are focusing about all the entities and also the relations or the relationships. What are the advantages and disadvantages of these ones? Yes, when it comes to advantages, these ER models are simple, effective, easy to understand, integrated. These are the set of advantages which we can have with these ER models or ER diagrams. And there are few disadvantages as well with the use of the ER diagrams: loss of information, limited relationships, no preservation for data manipulation, no industry standards, and data inconsistencies are there, missing missing cardinalities are there. These are some set of disadvantages as well as advantages here with the use of this ER diagrams. Then another data model will be the object-oriented data model. In Java, have you done Java in this course? Still not. When it comes to Java, in double OP, I mean the object-oriented programming languages also, they are the best example, the best example would be Java. So when it comes to object-oriented data model, here data and behavior. So for this, what are the advantages or what are the users we can have with this object-oriented data models? Yes, first we can consider about the data and the behavior. It will help us to combine data and behavior. When it comes to behavior, that is the properties of this data or the fields, or else all the methods within the objects, and it will helps to represent real world entities as well. These are data and behavior. And the next one will be inheritance and the polymorphism. So for the inheritance and the polymorphism, you will be learning these ones in future in the double OP courses. So for the inheritance and the polymorphism, what we have is it will helps to, or it will supports the inheritance. That's what we call the parent-child relationship. It's also kind of an inheritance as well. So for the supports inheritance, and it will helps to allow objects to inherit properties and methods from the parent classes. දෙමාපියන්ගේ තියෙන ගතිගුණ ළමයින්ට එනවා. So that's what we called as inheritance. And for the encapsulation, encapsulates data and methods within object, protecting internal data and providing controlled access as well. That's also there in this object-oriented data models. So basically in object-oriented data models, we have objects. Objects කියලකුවම ගොඩාක් වෙලාවට classes එක්ක තමයි අපි handle කරන්නේ. Java will be the best example for the double OP language. So මෙතන තියෙනවා object-oriented data model. Again, we have the advantages as well as disadvantages. When it comes to advantages, the power of inheritance handling complex data types and the scope for extensibility as well. For the disadvantages, now what are the disadvantages of this double OP or object-oriented data model? That is the complexity of data model, and resulting from its integration of the features of both the object-oriented and the relational data models, and also can sometimes make it quite challenging to manage these ones as well. So the previous ones, it's all about the relational data models. Now here for the NoSQL, non-SQL data model, this one is actually for unstructured, because the previous ones, whatever we discussed so far, we can use it for structured, we can use them as structured data models. NoSQL will be an example for the unstructured or else semi-structured. Anyway, for the semi-structured means it has the both qualities of structured and unstructured. Anyway, for the semi-structured also, it's also we can consider as a unstructured one as well. This NoSQL data models, we are using it for unstructured data. Why we use this one? For the NoSQL one, we have the flexibility and also we have the scalability properties, and also we can use this NoSQL for big data sets as well. When it comes to flexibility, offers a greater flexibility in data structures, supporting semi-structured and unstructured data formats. And for the scalability, we have designed for handling massive data sets and high volume data operations. And for the big data concepts, now, yes, it's well suited for handling big data where the relational models may become too complex as well. As I told you, for the semi-structured data models, a flexible approach that allows for both structured and unstructured data. It uses tags or key values pairs to organize data elements as well. Here, what you should know is basically for the NoSQL data, now, where we apply this NoSQL, that is when the data set is semi-structured, or else when the data set is unstructured. So what are the examples? We have JSON query language, and also XML queries, and also YAML as well. These are the example languages which we can use as semi-structured data models. So for the JSON now, it's commonly used for data exchange and API communication. And for the XML queries now, it's it offers a hierarchical structure for representing data, often used for document storage and web services. For the YAML, YAML, that is for a human readable format known for its simplicity and also the clarity. So these are the examples for semi-structured data models. So at last, we have the conclusion, that is how we choose the right model for the entire given concept. First thing you should know, we have to know about the data structure, whether it's complex or not, whether it's structured or not, or semi-structured. Likewise, we should have a proper understanding about the entire data structure. Once we have the understanding about the data structure, then we should know about its performances as well. When it comes to performances, we can evaluate the performance requirements of our database. The last point we have to think when we choose the right model, that is the scalability. Determine the scalability needs for your data storage and retrieval as well. That's what we have. Then we are moving to the ERDs. We are going to draw these ERD diagrams. Have you all drawn these ERD diagrams before? Yes. Yes. So then we'll just have a small discussion about that, and then we'll also do some exercises. So for the, have you used draw.io earlier before? Yes. Okay. Then for the introduction to ERDs, ERD means entity relationship diagrams. So basically this entity relationship diagram is equals to visual representation of data and also relationships as well. Why we use this ER diagrams? That is actually to plan kind of a database design before we are going to implement the entire database. So we can design the entire database with the use of these ER diagrams. So it's easy for us to handle. Then what are the components of this database or what are the components of these ERDs? We have entities, we have attributes, and also we have the keys and the relationships. So each and every component we discussed in the theory part. What are the examples? If we consider about the hospital systems, we have doctors, patients, appointments. These are the examples that we can have. Okay. Now, entities and the attributes. What are the entities and what are the attributes we have? So, entity means anyway, maybe it's an object or else maybe it's a concept. For example, either doctor or patient. Likewise, we can identify the objects which is related to the entire context. When we think about these entities, we have the strong entities as well as we have weak entities. How we define these strong entities and weak entities separately, For the strong entity now can exist independently in the database. They don't, they will not, they don't want any other objects or any other entities to help them to live in this entire scenario. They are independent from the other database components or the entities. So, and also for the strong entities now, those ones has a primary key that uniquely identifies it. But when it comes to weak entities, for the weak entities, they cannot exist alone. They can't be, they can't stay alone. They will always depends on another strong entity. Okay. So, and also for these weak entities, it does not have a primary key by itself. And also these weak entities, basically its users, uh, it's a combination of these foreign key or a partial key as well. Anyway, for the strong entities now, they can live without any other components or without any help from the others. It's kind of an independently living one, can exist independently throughout the entire database. But for the weak entities now, it's not like that. Those ones are depending on a strong entity. For the attributes, properties of entities, for example, maybe name, age, school name. Likewise, we can define any attribute names. When it comes to attributes, we have simple attributes. Simple attributes means for those attributes, we can't divide it into further. And we have the composite attributes. For the composite attributes, that means the best example is the address, because we can have, now when it comes to address, there's your house number, and then we have the street name, and then we have the village or the town name, and then we have the country, and then the postal code or the country code. Likewise, if we consider about your postal address, it's also kind of an it's connected with all those, the rest of the, again it combines with those informations, house number or the apartment number and the street line. Likewise, so for those kind of attributes, we call them as the another, what we call the composite attributes. But the other one will be, other one is the multi-valued attribute. For the multi-valued attribute, the best example is the phone number. A person can have multiple another for can a person can have multiple phone numbers, either a mobile number or a dialogue number or a hutch number. එකම පුද්ගලයාට phone numbers ගත්තොත් phone numbers තුනක් තියෙන්න, තුනක් හෝ තුනකට වඩා වැඩි ප්‍රමාණයක් තියෙන්න පුළුවන්. So for those attributes, we call them as the multi-valued attributes. And at last, we have the derived attributes as well. Derived attributes කියලා කියන්නේ, for example, date of birth කියලා කියන එකෙන් we can derive birth year, birth month and the birth date. Likewise, we can divide it into more further data නේ. එතකොට මෙන්න මේ විදිහට we can have 4 separate attributes. So one thing that is for the simple attributes and also the composite attributes and also the multi-valued and also the derived. Okay, just have a read, just look and read it. I'll also turn on the exercises once. So in here, the examples, they have given the examples for the doctor now. The properties will be doctor name, qualification, email, those ones. And when it comes to prescription will be an weak entity because prescription එකක් තියෙන්න නම් there should be a doctor as well. Otherwise, we can't have a prescription. මොකද වෙන කාටවත් prescriptions දෙන්න විදිහක් නැහැනේ. doctor කෙනෙක් ඉන්න ඕනේ. doctor මත depend වෙනවා ඒ prescription කියලා කියන attribute එක. Okay. Now, when it comes to entities set, so for the strong entities now, we are using a rectangle. And for the weak entities now, always we are using the double line. It was a simple attribute now, oval shaped curve. For the composite attributes, something like this. And the single valued attributes, define karanne. We are using normally the oval shaped one. If it's multi-valued now, again it will be with two lines. Then derived one now, we can use a dashed line, oval shaped one as well. For the relationships now, we can use the diamond shapes. There also for the strong relationship, we can use the diamond shape, and for the weak relationship now, we can use the double lined diamond shape. Okay, so these are the symbols that we are using to draw or design the entire what we call the entire what we call this ER diagrams. Okay. Then for the ERD mapping, for the mapping rules, we have the strong entity nang tables, weak entity nang tables with foreign keys, and we have the cardinalities as well, 1 to 1. It will always merge for a foreign key, and also 1 to many, that means foreign key on many sides. For the many to many nang, it would be a junction table. I'll explain these ones with an example so that it will be easy for you to handle. The example will be student enroll courses, then the tables will be student course and environment. Okay, these are the theory parts that we have. So we'll do some few exercises. Okay, so this one is the first example. ERD practice exercises. So for the can you start drawing this? For the exercise one, the problem is a company database needs to store information about employees identified by now the properties SSN, that means the social security number, with salary and phone as attributes. And for the departments identified by, identified means anyway the properties of this entire department, that is department number DNO with D name, that is for the department name, and budget as attributes, and children of employees with name and age as attributes. Then the second one, that is employees work. Now these are the constraints. The second slide, employees work in, now the in the previous slide we just identified about all these what we call entities. We had three entities there. If you look at if you read, okay, first read the question, otherwise I'm only talking now. So here when it comes to entities, we have the employee entity, and also the department entity, and also the children of employees. These are the main three entities that we have, entities, and also we can figure out or identify about the attributes as well of each and every entity. Now in the second slide, they have given us all the relationships. So employees work in departments. Each department is managed by an employee. A child must be identified uniquely by name when the parent, who is an employee, and the assumptions also given. Assume that only one parent works for the company. You can figure out cardinalities from that. Is not, we are not interested in information about a child once the parent leaves the company. So we are keeping those informations until the parent also working under us. So draw an ER diagram that captures this information. This is the question. Okay, start drawing that. For the first slide, that is for the this, and then for the second slide, okay, first take a picture on this so that you can, for the first one we have this. I don't know whether it's clear for the last row. This one is for the first one, and then second set, here we have the relations. Here we have the relationships among these ones. Now you have to draw the AR diagram and capture all the informations. completed or still doing? Still doing. So what are the key constraints or the relations we have? Employees work in departments and each department is managed by an employee. A child, a child must be identified uniquely by name when the parent, who is an employee, assume that only one parent works for the company, is known. So we have only three entities. One is employee, the other one is department, and the other one is child. So for the employee, we have a social security number and the salary, phone number, and the department number. Those are the employees' attributes. So for the departments, again, we have the department number as primary key. Then we have the department name and also budget. Then for the child's name, we have the child name and the social security number and also age. So when it comes to relationships, in between the employee and the department, we have the works in relationship, or else we can have the manager's relationship as well. And for the employee and the child now, again, employee has a child, or else child is a dependent of the employee. Likewise, we can have uh, relationships in between those ones. Yes. So, what are the primary keys of these ones? So, when it comes to now the employees, we have the social security number as the primary key, and in department we have the department number as primary key, and for the child now again we have the child name and the social security number both as the primary keys. දෙකම තියෙන්න පුළුවන් primary keys විදිහට. හරි. එතකොට foreign keys විදිහට ගත්තොත් for the first one salary, phone number and department number, and for the departments වල the rest of the numbers, rest of the attributes when a department name and the budget. For the last one, age will be the other attribute that will represent this child. So the phone number will be a multi-valued attribute. So you have to represent it like that as a multi-valued attribute. Then what else? Yes, other than that, nothing. All the other ones are strong relationships as well as the strong entities as well. Okay. Then for the second exercise, you just you can download it as an image, or else you can download the workings as an PDF format as well, as I can remember in draw.io. So keep it with you so that I'll send you a link to submit those ones, so that you can submit those workings to that link as a submission link. Then for the second question, For the second question, this is a little bit big one. Okay. So, although you always wanted to be an artist, you ended up being an expert on databases because you love to cook data and you somehow confused database with data based. Your old love is still there, however, so you set up a database company, Artbase, that builds a product for art galleries. The core of this product is a database with a schema that captures all the information that galleries need to maintain. So each group, this is a new one. So galleries keep information about artists and their names, which are unique, birthplaces, age and style of art. For each piece of artwork, the artist, the year it was made, its unique title, and its a type of art. For example, painting, lithograph, and sculpture, photograph. These are the attributes of that, and its price must be stored. And the pieces of artwork are also classified into groups of various kinds. For example, portraits, still lifes, works by Picasso, or works of the 19th century. A given piece may belong to more than one group as well. Okay, more than one group as well. And then each group is identified by a name like those just given that describes the group. Finally, galleries keep information about customers. For each customer, galleries keep that person's unique name, address, total amount of dollars spent in the gallery. That is very important. And the artist's and groups of art that the customer tends to like. Draw the ER diagram for the database. So this is the first slide. Okay. And then this is the first slide. And then this is the second slide. Then this is the third slide or the last slide. Okay. Okay. This will be the last question. So do that as well. Just read one more time. Do you want me to share the question again? Okay. This is the first part. First slide, second slide, and also we have the third slide. Read this carefully so that I'll also help you to figure out what are the entities and the relationship of relationship. If you read it, if you read it carefully, you can see there are four main entities. First entity is group, the other entity is artwork, then the third entity is the customer, and the last entity will be artist. These are the four main entities that we have. Okay, were you able to complete this? So in group, each group is identified by a name. Yeah, it starts. Okay. Although you always wanted to be an artist, you ended up being an expert on databases because you love to cook data, and you somehow confused databases with the database. Your old love is still there, however, so you set up a database company, Artbase, okay, that builds a product for art galleries as well. The core of this product is a database with a schema that captures all the information that galleries needs to maintain. Then galleries keep information galleries keep information about artists, their names, which are unique. Okay, so what are the things we can have? We can have groups, we can have groups and also the customer, and also the artwork and also the artist. So under this groups, we have only the name as a primary key. Name as a primary key, and there in the artwork we can have the title and the name as the primary key and the foreign key, title and the name. Then the rest of the values, year, type, price, will be we can use them as the attributes. And for the customer now, we have the primary key as customer ID, and also for the foreign keys, we can have its name and the title. I think for the customer, we can have a combined primary key, that is from the customer ID, name, and title. All these ones, or else you can use the customer ID as only the customer ID as a primary key. And for the artist now, we have name and title. For the birthplace, age, style, we can have them as the rest of the attributes. Once we figure out those ones, anyway, we have a very small number of relations. One will be the group has artwork. Okay, the group has so the group has uh, yeah, you just complete some of these ones. Group has artwork, and also artwork is classified by group. Something, is there something like that? Unique title and the stored piece of art are also are, yes. Pieces of artwork are also classified into groups of various kinds, Kiran. That means the artworks is classified into groups. That's also a relationship. The other one is the group has artworks. So another relationship would be artist paints artwork, and the other way, the passive form, you can use it as artwork created by artists. Artworks created by artists. Then among the customer and the artists, we have customer likes artist. Yes. Anyone called me? No. So one relationship will be customer likes artist, and in between the customer and the group, we can have customer likes group, and also a group is a part of the customer. A customer is a part of the group. Sorry, customer is a part of the group. So you have to figure out what are the relationships they have defined here. So this one, pieces of artworks are also classified, and for each, for each piece of artwork, the artist, the year it was made, these are unique titles. That means the what we call attributes of that, and also then they have each group is identified by a name describes. Finally, galleries keep information about customers. So for each customer, galleries keep that person's unique name, address in the groups where the artist and see the last line, and the artist and the groups of art that the customer tends to like. We have only 4 relationships. Okay, it's fine, right? Can you manage these ones? I didn't draw, but I'll also draw it and publish in your LMS so you can mark your ones. You just keep your PDF for the PNG version of those questions, so it will help you to mark. Any questions? Is it okay? Fine. Huh? Huh? නෑ attributes type of part එකේ attributes තමයි අර දීලා තියෙන්නේ. එතකොට ඒක මේක තමයි කනෙක්ට් වෙන්න ඕනේ. ඒ ටික කනෙක්ට් වෙන්නත් ඕනේ. දැන් type of part එකේ attributes නේ. එතකොට ඒවා ආයි කනෙක්ට් වෙන්න ඕනේ අර oval shape එකයි. attributes කොහොමද අපි oval shape එකෙන් තමයි represent කරන්නේ. so ඒක මේකේ වටේ තමයි ඒක ආයි බෙදෙන්නේ නෑ අර මේ parent wise එහෙම යන්නට බෙදෙන්නේ නැහැ. යාගේ attributes නම් always මෙයාට. අනිත් එක මේ සමහරක් වෙලාවට දැන් උතන තියෙන පොඩි examples නේ. මෙතන අපි අඳිනවනේ relationships. ඒ relationships වලට සමහරක් වෙලාවට attributes එනවා. එහෙම આવොත් එහෙම තියෙන example එක මම කරන්න ඊළඟ දවසේ. එහෙම આવොත් ඒක ආයි connect කරන්න ඕනේ අර වගේම direct lines දාලා ඒකේ attributes නම් ආයි ඒක oval shape දාන්න. අන්න හරි. එතනට එයාගේව එන්න ඩිෆයින් කරන්න ඕනේ. foreign key එක primary key නම් underline කරලා foreign key එක represent කරන්න ඕනේ. ඒකත් underline කරලා primary key එකට පස්සේ. يعني ඉස්සෙල්ලාම define කරන්නේ අපි normally primary key එක. ඊට පස්සේ තමයි foreign key එක. foreign key එකත් keys නම් if it's keys නම් you have to underline it and keep it. අර attribute එක ඇතුලේ නම ලියනවා. දැන් පළවෙනි එකේ නම් group එකේ නම් final group එකේ නම් primary key එක වෙන්නේ name එකනේ. ඒක හරි. එච්චරයි එතන තියෙන්නේ. but for the artwork නම් title කියලා කියන එක මොකක්ද? primary key එකක් වෙනවා and for the foreign key නම් name එක කියලා කියන එක ඔයාලට foreign key එකක් කරගන්න පුළුවන්. ඒතර name එක දෙවනියට ලියලා you have to underline. keys නේ keys නම් anyway unique keys නම් ඒවා underline කරලා තමයි represent කරන්න ඕනේ. Okay? Okay, then that's all for today. Yes, anyway, now it's almost 4:46. So, yes, data modeling part and the ERD diagrams, we are done with this. So, next week again, we have to do the, I think, normalization and the advanced ERD. So, in that advanced ERD, I'll do it further more. Yeah, that's it. If there's no any questions, we can wrap it up the session. Ask your colleagues or the classmates to participate for the classes. දාලා තියාගන්න මම අප්ලෝඩ් කරන්න ලින්ක් එක හදන්නම් මොකද මට පර්මිෂන්